Hi, and welcome to Meetings in Math. You are here for 5.6a direct variation and proportional relationships. Our essential question today is, what are the characteristics of tables and graphs showing proportional relationships? Today you will need your Jaguar dots on 5.6a, a pen or pencil, a highlighter might be useful, you may need a calculator, bring with you your positive attitude, determination, and always your problem-solving skills. So let's begin. We're going to start with this table that is looking at meters and centimeters. There are 100 centimeters in every meter, and we're going to complete this table. We're going to begin by looking at the ratio of centimeters per meter, keeping with this idea of our constant proportionality comparing our y's to our x's, which means we have 100 to 1. So now let's set up our proportion. Remember, a proportion is when you take two ratios and you set them equal to each other. So we are going to say 100 is to 1, and we're going to look at this first one as y is to 94 hundredths. We're using y because that is our unknown, and 94 hundredths is our x, or our meters. The reason I like using the centimeters to meters is I make sure that I keep everything in the same place. So centimeters is on the top, and meters is on the denominator. And now we solve this using inverse operations. So I am going to multiply both sides by 0.94. And when I multiply, and notice I dropped the 1 because that's 100 over 1 is just 100. And so when I multiply both sides by 0.94, I end up with y is equal to 94. So now let's look at our next one, 1.67, and we're going to do it the same way. So why don't you go ahead and solve it using proportions, and then come back and check your answer. So we set up the same proportion, 100 is to 1, as y is to 1.67, and then that's y divided by 1.67, undo division with multiplication. So 1.67 multiplied on both sides, and so we end up with y is equal to 167. So now before we find 57 and 24 hundredths, we're actually going to look at the constant proportionality and see how that can help us to find our missing information. To find the constant proportionality, we need to remember that the constant proportionality is k, or k equals y over x, or k is y divided by x. And we have three different options here, but let's go ahead and use our simplest one, which would be 1 and 100. So y is equal to 100 and x is equal to 1, and so we'll just use substitution. So now we know that k is 100 over 1, or let's go ahead and just simplify that to k is equal to 100. And now we can use that to help us write the equation for that proportional relationship. And having an equation then means we can use substitution to help us solve it. So now that we have an equation started, we can use substitution. So we know k is equal to 100, so we'll put that in place of k. So now we have this general form of an equation. We now know we can use this equation to find any information when we're talking about centimeters and meters. So now when I have x meters, I know I can find my centimeters by multiplying anything that's in this left-hand column by 100, and that will give me my value for y over here. So let's go ahead and use this new equation to help us find 57 and 24 hundredths. So now I have my equation, y equals 100x, and I know I can use that to find anything that I need if I have the meters to change it into centimeters. So now I have 57 and 24 hundredths. And what I'm going to do is I'm going to now change my x, 57 and 24 hundredths, into my centimeters y using substitution. So y equals 100x, I'm going to substitute that in. So y equals 100 times 57 and 24 hundredths. And so now my y is equal to 5,724 centimeters. So what we've been looking at is this equation or proportional relationship y equals kx. And again, k is called the constant of proportionality, and it also has another name called direct variation. So now let's look at another situation where we're comparing two different runners, Han and Claire. Han and Claire are running laps around the track, and their coach is recording their laps at the end of laps 2, 4, 6, and 8. And here's their information. At the end of Han's run, after lap 2, his time was 4. After lap 4, Han ran 9 minutes. After 6, there was 15 minutes, and after lap 8, it was 23 minutes. Claire's run after 2 was 5 minutes, after 4 was 10 minutes, after 6 was 15 minutes, and after 8 laps was 20 minutes. And what I'd like you to do right now is we want to figure out K, or we want to figure out our ratio Y to X for each Hans and for Claire's. So I want you to pause the video and complete the table and make sure you reduce each of your ratios into the smallest fraction, and then come on back and we will compare what you have to what I have. So for Han's run, the first one was 2 minutes per lap. The second one was 9 minutes per 4 laps, did not reduce. The next one was 5 minutes for every 2 laps, was the reduced version. And the last one was 23 minutes per 8 laps, and it did not reduce. For Claire's run, it reduced to 5 minutes for 2 laps. And the next one was 5 minutes per 2 laps. And the next one was 5 minutes per 2 laps. And the last one was reduced also to 5 minutes per 2 laps. And so our question now that we want to ask is, which relationship is proportional and how do you know? Well, remember, proportional means that they're going to reduce and have the same K. So if I look at this, I can see that this K, these are not the same. So this cannot be proportional. So this one is not proportional. But if we look at this one right here, these are all 5/2. Every one of Claire's runs was 5 minutes for 2 laps on every single time that we took a measurement. So Claire's run is proportional because K is the same. Every single entry was the same. Han's run was different every single time. In other words, Hans did not run consistently, where Claire did. So Claire's run is proportional and Hans is not. Now that we know that Claire's run is proportional, let's go ahead and write the equation for that run. In other words, if Claire is training for a marathon, can we figure out how long it would take? In other words, we just want to figure out what would that proportional relationship look like. So we start off with the general function again, or the general relationship y equals kx. And we need to figure out what k is. But remember, k is just y over x. We already have y over x. That's what all of this is. This is y over x. And so we're going to substitute in our 5/2 in for k. We know that. So our proportional relationship is y equals 5/2 x. So now let's look at a different situation. We're looking at 3 different cubes. Cubes have the same length, width, and height. One that's a 3, one that has 5, and one that has 9.5. And we're going to look at total edge length, surface area, and volume. And I did some of the hard work for us already on this, and I completed the tables for us. I looked at the total edge length of each cube in table number 1, the surface area of each cube in table number 2, and the volume of each cube in table number 3. And what I want to know is which one of these relationships is proportional and explain why. So if we look at table number 1 to begin with, we want to compare, again, y to x. So if I compare k equals y to x on problem number 1, 36 to 3, and then I want to reduce it. We always reduce it so that we're comparing the smallest fraction. We're looking at equivalent fractions. So that is 12. So now I want to do the next one, 60 to 5. When I reduce the 60 to 5 and I reduce that, I also get 12. So I'm going to keep on going, and I'm really going to hope that this is what? I'm going to hope that this is also 12. When it's y to x, 114 over, I change that to 9.5, it is also 12. So this right here, because k is the same for every single one. This right here is proportional. So let's look at number 2. 54 to 3 is 18. 150 to 5 is 30. I'm not going to go any further because I know right now these are not equivalent. That is all I need is for one of those numbers, one of those relationships to not be the same. And I get to say they're not proportional. So that one is not proportional. And I'm moving on. So what I'd like you to do for problem number 3 is I'd like you to determine if you think that one is proportional or not proportional, and then come on back and check your answer. So 27 to 3, that reduces to 9, and 125 over 5 reduces to 25. And again, not the same k, so they cannot be proportional. So now that I've eliminated number 2 and number 3 from being proportional, writing an equation of the cube with the side lengths. So there's only one that I have to write the equation for because we only have one that's proportional. And remember, it's k was equal to 12 in this one, and we're putting it into y equals kx. So our answer is y equals 12x. It's just substituting in our k into this y equals kx. So because they gave us a variable of s right here, we do need to use the variable that they gave us. So we are going to use 12s to represent this expression. In our last one, we're going to look at our 6 different kinds of equations, and we're going to just predict which one of these would be a proportional relationship. So right now, what I'd like you to do is I'd just like you to put a check mark next to the ones that you think are going to be proportional relationships. Now that you've done some predicting, we are going to use a table to actually figure this out. Now we're going to do a little bit of movie magic, and there's our answers. So now that I've done some movie magic for you, and we're looking at these, I want you to look at the all-important y over x, because remember, that's what's helping us determine whether or not these are proportional, because y over x is your k. And to be proportional, your k has to be what? Your k has to be the same. So do these results change your predictions? Which one of these are in fact proportional? Keep in mind, what points do all proportional relationships need to go through? All proportional relationships need to go through the point 0, 0. Keep this in mind as you look at your answers, and also keep in mind that k needs to be the same. Those right there are your 2 proportional equations, y equals 4x and y equals x over 4. We could rewrite y equals x over 4 as y equals 1/4 x. So some things to note. This right here did not work because it was 2 terms. This one did not work because our x was in the denominator. And these ones aren't working because we have exponents. So what do the equations of proportional relationships have in common? There's no exponents. They have a number in front of the x, and it can be a fraction. There's an x in the numerator, not the denominator. Another thing that's not here that maybe we could go back and look at real fast, that there's only one term. This one had 2 terms. So there's lots of things that we could talk about. Maybe not all of them were listed. Thank you so much for joining us for direct variation and proportional relationships. What I'd like you to do now is write down 2 things that you now know about proportional relationships that maybe you didn't know before, or is a little more clear today after this lesson. Thank you so much for joining us, and remember, be kind to one another because we can all use some extra kindness in our lives. Bye for now.